Hello guys, now again one more numerical problem. Now this problem which I have selected, it is on gravitational field and gravitational potential. Now let us read the problem out. 3-point masses are placed on the vertices of an equilateral triangle having side L. Okay. Now we need to find the gravitational field and gravitational potential at the centroid due to these three masses. Okay. Now we have this diagram here. I have made the diagram. A, B, C is the equilateral triangle and masses M, M and M, they are placed on the vertices. Now if you see here, we want to find the gravitational field at the centroid. Correct. Now here we need to do little geometric construction. What I know is O is my centroid, and if I, for an equilateral triangle, the median, okay, median is also perpendicular to the opposite side. Okay, it is this median, let us call it AD, is perpendicular to BC and it bisects. You have this triangle ODB, correct? In ODB, you have this 30 degree, this angle is 30 degree because equilateral triangle has got all the three angles 60 degree, and so this median is going to bisect that angle. So I have this 30 degree and this side is L by 2, correct, since AD is the median. So I take cos 30 is equal to adjacent, that is BD, upon hypotenuse OB. So that means OB is equal to BD. Now what is my BD? My BD is L by 2 divided by cos 30. Now what is cos 30? It is root 3 by 2. So my side OB is equal to L upon root 3. Now why did I do this? Because I want to find the gravitational field at point B due to all the three masses, and then over here by simple geometry you can see that OB is equal to OA is equal to OC. So I can write here that therefore OA is equal to OB is equal to OC. Now coming to gravitational potential. Now like electric potential, what is gravitational potential? It is the amount of work done in bringing a unit mass from infinity to that point. It is the unit mass, correct? So my gravitational potential, let us call it E, is going to be equal to G M upon R square. That is the formula. Now here R would be OA and OB and OC. So now my E1, so E1 is equal to Gm upon R square equal to Gm upon okay, so and that is going to be equal to E2 and that is equal to E3, correct, since the masses are equal, M, M and M there, correct. Now see, it is very important to note here that the magnitude of all the three potential three fields are same, the directions are different. Okay, now what do we do for direction? Now it is a vector quantity, right? Now if you see here, I have marked the vectors by the red arrows. So E1, E2. Now we have to find the resultant of three vectors, correct? So we will take two at a time. So we will take E1 and E2 first. What is the angle between E1 and E2? Is it not 120 degree? Angle between correct. Now we have to find the resultant of E1 and E2, and then we will find resultant of the earlier resultant and my E3, and then we will get it. Now how do we do this? Two vectors originating from the same point having some angle between them. We use parallelogram law of vector addition, correct? So my resultant, I would say, I'll call it R, okay, or then I'll call it R1. So that would be equal to, by parallelogram law of vector addition, it is E1 E1 square plus E2 square plus 2 E1 E2 cos theta. Now angle between E1 and E2 is 120 degrees, that is my theta. What is my E1 equal to E2 equal to E3? It is Gm upon R square, and what is my R? L upon root 3. So this is going to be equal to Gm upon L upon root 3 square. So that 3 will go on top, and I'll have this L square here, correct? Now I substitute that here. So it is going to be equal to E1 square plus E1 square plus 2 E1 square cos theta, correct? So anyway, I'm going to take E1 square common, and then that can directly come out of the square sign, the square root sign, correct? So I'm going to have 3 Gm upon L square, and under root I'll have 1 plus 1 plus 2 into, now cos of 120. What is cos of 120? Cos 120 is cos of 90 plus 30. Cos 90 plus cos 30, and it is going to be equal to minus half, correct? And then square root of that. I cancel this. So 2 into minus half is equal to minus 1. So 1 minus 1 is 0. So what I'm left with is only 1 in the root sign. So my resultant here is 3 Gm upon L square. Is it not amazing? Two vectors having this magnitude have resultant same, correct? So my value of this R1 here, it is equal to Gm upon L square in this direction, correct? Now what? My E3, what is the magnitude of E3? Again, it is 3 Gm upon R square, L square. So 3 Gm upon L square there and 3 Gm upon L square there, they cancel each other, and finally what is my what is my gravitational field over there? My gravitational field over there is going to be 0, correct? So net field, now when I say net field, it is net gravitational field, I'm being a little lazy here, would be equal to 0, right? So that is how it is. Now there is something more to it. What is the second part of the question? The second part of the question, it asks you about the gravitational potential. Now gravitational potential, it is not a vector quantity, isn't it? It is a scalar quantity. So then for gravitational potential, we need to add the potentials, correct? So I'm now going to clear this, okay? You can watch it later. Now what is my gravitational potential? Let us call it V here, and that V is equal to, do you remember the formula for electric potential? It is K into Q upon R, correct? So here it is going to be equal to G into M divided by OA, OB and OC, correct? So it would be OA, I'm going to write V1, and V2 and V3 are going to have same magnitude. But now here the gravitational potential is going to be having a negative sign. What is the reason? The reason is the mass is whatever the mass we are going to have at that point, it is going to be bound to each of these masses M there, correct? So magnitude of each is going to be equal to minus G m upon, what is this, OA and OB and OC? It is L by root 3. Correct. So it is going to be minus root 3 gm upon L. Now my effective potential due to all the three masses, it is going to be equal to the scalar sum. So my net V is equal to V1 plus V2 plus V3, and that is going to be equal to minus 3 root 3 gm upon L. So that is my gravitational potential, net gravitational potential at point O. So that is how we deal with the gravitational field and gravitational potential. Thank you so much.